Hi everyone, welcome to my channel. In this video, we'll see about compensation theorem. The statement for compensation theorem is in any linear bilateral network consisting of active and passive elements, if the impedance of the branch carrying current I is changed by dou Z, then the change of voltage or current in each branch of the network is that the voltage or current that would be produced by an opposing voltage source of value Vc introduced in the altered branch of deactivation of original sources. So we'll see that statement with an example so to understand betterly. So let us take the given network. He is this one. So having a voltage source and impedance Z1 and Z2 which are connected in a series. So let the current I is flowing in the given network. For example, if the impedance Z2 is changed by dou Z, that means adding to the existing impedance of Z2, we are adding dou Z, so that here the impedance value is increased. Whenever the impedance value is increased, there is a change in the current here that is indicated as I dash. So by compensation theorem, to calculate the change in current, here we are doing one thing, that is we are replacing the voltage source by a short circuit, that is deactivating of the sources. Then to find the change in the current here, we are adding a voltage source with opposite polarity, that is Vc. So this Vc is called as a compensation source, whose value is nothing but the current I into dou Z, where I is the original current in the given network and dou Z is the amount of impedance that is added to the existing impedance. So this Vc, that is a compensation source that is added to the modified impedance source that is shown in the figure. So by upon adding this compensation source, del I, that is a change in current that is calculated from the circuit by the formula. So by applying simple KVL, we can find the value of del I, that is a change in current, where del I is nothing but I minus I dash, where I is nothing but the original current that is flowing in the given circuit. I dash is nothing but the current which is flowing in the circuit, that is impedance is modified. So therefore del I is nothing but the change in the current that is calculated by applying the KVL in the given network. So this is the compensation theorem statement and example. So we'll solve a problem so that you can understand betterly. So what is the meaning of a compensation theorem? So calculate the change in current in the network by using compensation theorem when reactance has changed to Z35 ohms. So here this is the given network having a resistance and reactance. Resistance value is 25 ohms, reactance is Z20. Now the reactance value is changed to Z35 ohms. So now he asked to find the current, change in the current by using compensation theorem. So before adding this reactance, so from the given network the current is calculated as 100 at angle 60 by 25 plus J20. So therefore current can be calculated as in the polar form or rectangle form is calculated here. So now if the reactance is changed to J35 ohms, so then the current in the given circuit also changes. Therefore the change in the reactance is denoted as dou Z or del Z. So that means here Z means here only the reactance part is changed. That's why we are mentioning as del X. So that is given as original value is J20 and the modified value is J35. Therefore the difference is minus J15. That means with respect to the given network here the reactance value is increased. So now we have to calculate the compensation source magnitude, that is Vc. Vc is equal to I into dou Z or dou X here. So where I is nothing but the current in the given network. So dou X is nothing but a change in the reactance. Therefore I into dou X can be calculated as 46.845 at angle minus 68.66 volts. After calculating the compensation voltage, we have to redraw the circuit by deactivating the sources that is given network. So then and also incorporating this compensation source in the network. So there is a deactivation of the given source and your incorporation of this compensation source, and the modified input reactance value is also shown here. So 25 ohm is the given resistance and J35 is the modified reactance here. So therefore the dou I, that is a change in current, that can be calculated by simple applying KVL here. So therefore VC by 25 plus J35. So the change in current can be calculated as 1.089 at an angle minus 123.12 amperes. Next, second problem is, so determine the current flowing in the branch AB if it is replaced with a 5 ohm resistance by compensation theorem. So in the given network, 3 ohm branch is nothing but the resistance connected between the terminals A and B. Now this resistance is replaced with a 5 ohm resistance, and he want to find the change in current by compensation theorem. So this can do also by normal method, but he mentioned in the problem by compensation theorem. That's why you have to do it by compensation theorem only. So before that, so first from the given network we have to calculate the equivalent resistance, and then current in the current from the total supply, that is current from the supply I. Then we have to find out the current in this branch 3 ohms. So the current in this branch can be obtained by current division rule here, that is 1.67 amps. Now if the 3 ohm resistance can be replaced with 5 ohm resistance, the current I2 also changes. Not only I2, all the currents will be also changes. So but here the element here changes means therefore the current I2 also will be changes. Therefore the change in resistance is nothing but 3 minus 5, that is minus 2. That means the resistance value here is increased. Therefore we have to calculate the compensation source by using the formula I into del R. So where I is nothing but the current obtained in the given network, del R is nothing but change in the resistance. Therefore the compensation source can be given as minus 3.33 volts. So after calculation of compensation source, we have to deactivate the sources in the given network. So then we have to add this compensation source where the element has got changed in the given network. Since the element is changed here, that is the terminals A and B, therefore we have to add this compensation source in the branch AB only. Therefore after incorporating of this voltage compensation source, so now we have to calculate the change in current del I2 here. Therefore the change in current del I2 is obtained by simplification of this circuit. So that del I2 can be calculated as 0.512 amperes, where del I2 is nothing but I2 minus I2 dash. So therefore the change in current I2 dash is calculated as I2 minus del I2, where I2 dash is the current in the original circuit, that is without modification of the resistance. So del I2 is nothing but change in the current that is obtained after incorporating of this 5 ohms resistance. Therefore the difference of these two current gives the change in current, that is I2 current now which is flowing in the network after placing the 5 ohm resistance, that is 1.158 amperes. Thank you.